Hey folks, this will be our third kind of practice problem for today. We're going to be talking about something called tetrahedral. All right, and the practice / example problem we're going to be doing is CH4. All right, so we know that carbon likes to have some valence electrons. It's got 4 valence electrons. And when we've drawn the electron dot structure for something like this, we'd have our hydrogens out here. We'd have those lone electrons near each other. And you'll remember that hydrogen only needs 2 valence electrons in order to be happy. Boom, 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 boom. And carbon needs 8. Boom. Cool. All right. This is probably one of the more complicated things for people to understand because of this electron dot structure. See, it looks right now that the hydrogens are as far apart as physically possible. But that's when we're thinking in 2 dimensions. When we're thinking about molecules, we need to think in terms of 3 dimensions. We need to be open to the possibility that our molecules are 3-dimensional because that's how the world actually is. Okay, so how do we do that? Well, carbon is still going to have 4 bonds. One bond will go straight up. One bond is going to kind of go off to the left like that at an angle. So it's got about 120 degrees. And if you think about it, if a hydrogen atom were to come partially out of the board and another hydrogen atom was to go partially into the board, we would have what we call a tetrahedral shape, where the hydrogen atoms are actually about 120 degrees, a little bit less than that, apart from each other. These hydrogen atoms are as far apart as physically possible because the hydrogen is partially coming out of the board, and these 2 hydrogens are as far apart as physically possible because this hydrogen is partially coming out of the board, and this hydrogen is partially going into the board. And the way that we show that with those bonds is by having this little triangle slowly get wider, as if the hydrogen atom is slowly getting closer to us. And the little kind of dashed line for this hydrogen's bond, it's slowly starting to get smaller, as if the hydrogen atom is getting further away from us, as if it's getting harder to see. And so that's why we have those different kinds of lines for our hydrogen atoms. And this is the correct kind of structural formula we'll be using going forward. Okay, so here's the challenge for you, is can you do a practice problem on your own for the tetrahedral shape? The problem that I would like you to try is going to be SiCl4, silicon tetrachloride. See if you can solve this problem, and then when you're ready, restart the video, and we'll see if... Okay. Here we go, let's go over this problem. I've already added in all of the valence electrons for my silicon and for my chlorine atoms. The chlorines all have 7, the silicon has 4. The chlorines are going to share one of silicon's valence electrons in order to be happy. And the silicon, it's going to share some of the electrons from the chlorines so that it is also happy. Okay, so here's kind of the tricky part. How do we create the structural formula? Well, just like the previous problem, we'll have our Si in the middle. And we're going to have one chlorine atom kind of coming down at an angle like that, one chlorine atom going straight up, and then we're going to have one chlorine atom coming out of the board, and one chlorine atom kind of going into the board. The one thing that you may have missed is you've got to remember chlorine has some unshared pairs of valence electrons. And we still need to include those unshared pairs of valence electrons in our structural formula. You guys may have probably picked up on the trend that I've done with the past 2 videos. Yes, the shape of this molecule is tetrahedral. I'll be posting a couple of practice problems on our Google Classroom page for you to try. Go ahead and try those practice problems. See you tomorrow. Bye.